We are recording, we are live. Hello, everybody. Thank you for joining us today in the Kubernetes SIG API Machinery meeting. We have a very nice agenda. Today is October 7th, 2020, this wonderful 2020. So I'm presenting the agenda. I will stop presenting to allow our first presenter today, Jason, to give us a demo of something cool they've been working on. Give me a second. Let me stop recording this. No, stop presenting. Okay. All yours.
All right. So hopefully that's coming through right now.
Yes.
So to give a brief overview, I decided to throw out a crazy idea on Twitter a few weeks ago. I've been working on a project called Tinkerbell that's, trying to bring kind of like cloud native infrastructure management into the data center. And one of the things that we started doing is we wanted to try to implement an event-driven workflow. And some of the things that we started implementing for that reminded me a lot of Kubernetes. And I kind of wish we could just reuse some of the Kubernetes API machinery and stuff to kind of implement some of the things that we were doing. And that brought me down this whole rabbit hole of, would it be possible to build a minimally viable and embeddable API server that has just enough components to be able to host and manage CRD type resources. And I know folks have talked about that various times over the past couple of years, but I had trouble finding any actual concrete implementations of it. So what I'm presenting today is basically the kind of proof of concept type work I've been doing about trying to actually do the thing. And, basically what is the goal? Be able to embed a minimal API server capable of supporting CRDs into a standalone application. The idea being is that I don't want to necessarily have Kubernetes as being a hard requirement for being able to expose these types of APIs. Also to avoid exposing all of the Kubernetes component command line flags that come along with some of the existing components out there, like the aggregated API server and the API extension server. I also wanted to try to avoid vendoring any libraries or importing anything from Kubernetes, because once you do that, you get into this whole big thing where you have to kind of lock all the dependencies in the Go mod file, and it's just not very friendly for people to kind of manage those types of projects. And basically just try to do a proof of concept to prove if it was even feasible or possible to do. Some of the other minor goals that I had was to try to avoid reinventing any unnecessary wheels. I didn't want to have to recreate and duplicate code from upstream if at all possible. I'd like to use what's already there and available wherever I can. Also, because this is embedding into an application, I want to avoid exposing unnecessary ports. So, in the example that I'll be showing in a little bit, it actually runs etcd and it runs the aggregated API server. And I didn't want all of these things to actually have separate HTTP endpoints. I wanted to be able to take advantage of some of the delegation services that are available. And there are two main use cases that I have in mind. One is a standalone use case where there will never be a need for an external Kubernetes server, and Kubernetes offers way too many things that you might not actually need for the application that you're building. And then the other one is kind of like a bootstrapping use case where it would be great to use Kubernetes once it's available, but in the case of infrastructure software and trying to recover from, say, like a data center outage, I wanted to avoid the whole chicken and egg scenario of having to have a Kubernetes cluster up before you can actually get your infrastructure management that's bootstrapping Kubernetes clusters up and running. And then the next thing, after I got this crazy idea in my head is like, what about the existing tooling? What can I use that's out of there? And probably the first place to go is a sample API server. It's more like kind of the Kubernetes, the hard way of API servers. It would be possible to build something using this, but it's not very user friendly. And I've really grown to like the CRD type tooling that we have, where it's really simple to define the types. It's really simple to define, the applications, and it's not necessarily tied to Go-based implementations. I want to be able to try to reuse some of that. But looking at the aggregated API server way, I took a look at API Server Builder Alpha. It has a lot of nice tooling, but it's still kind of tied around the command-based architecture, where it's like you get a Cobra command and you run the Cobra command, and kind of the same with API server runtime. And I'd really love to be able to leverage some of the QBuilder tooling, but that kind of assumes that you already have the Kubernetes cluster up and running. So, and then then it's like, okay, can I dig into the underlying libraries? And one of the first things that I found is that there's a lot of verbosity in trying to use the underlying libraries directly. So it doesn't really seem like a feasible way to tell people to kind of like implement this on their own. There's a lot of replicated configuration, especially when you talk about delegated API servers. There's you have to pass some common config among all of them. There's separate config that needs to be done. There's a lot of complexity there. And all of this is really highly tied to Cobra. You define the options, and then you complete the options, and then you take that and you input that into the config, then you complete the config, and then it goes into the command, and so forth. And I wanted to try to kind of see if I can focus on a more API native model. And quite a bit of the functionality, especially when you get into like the delegated API server bits, all of that functionality generally lives in KK, and it gets back into that same issue of vendoring in KK. And even if you could vendor it in and it wasn't in KK, if you tried to include Kube API server today, you get all of the types, all of the groups that are exposed there. And I really wanted to try to limit this down to just the bare minimum needed to support CRDs. Like, the idea is never that this API server use would never support deployments or replica sets or anything like that. So having that even available is kind of overkill. So that going into kind of like the standalone kind of deployment model, which is kind of where I started the implementation today, just for the proof of concept. Basically you can have a client that just uses the native kind of Kubernetes client Go based tooling, talk to this embedded API server that's running inside of your service. It can host a local etcd there, and everything being self-contained. And with that, let me go ahead and switch over to a different window. All right, and over here, I've already built kind of the binary for this, so I can just go ahead and run it. And if I run this, it's starting up etcd, it's starting up the aggregated API server, and it's starting up the API extension server. And if I start a new window, I'm just going to copy and paste this to not have to remember all of it. If I list out the API resources, currently the only things that are exposed right now are API services and custom resource definitions. Obviously, there's going to need to be more implemented to fully support, non-trivial CRDs. But this was enough to get things up and running and just prove that I could run the minimal server needed to just support cluster scoped CRDs. And I've kind of stolen a couple of examples directly out of the QBuilder examples. So just a simple cluster scoped CRD definition. I can create this. And if I go back in API resources, I do see the Admiral resource there. And if I wanted to create one, again, just strictly out of the QBuilder examples, I can create that. And it's admirals. Oop. I made him mad. There we go. I don't know what happened in that other window, but if I do a get, I actually see that the resource is there and, you know, populated the way that I expect it to be. So from the basis of a, you know, single version stored CRD that is cluster scoped, this project is already functional. And let me switch back. And I apologize if anybody's, I saw that there were some things in the comments, but I'm not able to kind of see that right now because lovely Zoom. But, you know, with that demo out of the way, you know, what's kind of missing? Configurability of pretty much everything at the moment. Everything is kind of hard coded around an embedded etcd that's listening on a Unix port, and, you know, everything's tied to kind of self-signed certificates, all of that stuff. So ideally being able to expose configuration there would be great. What I've kind of taken to calling like the core components, the bits that are needed out of core just to support the CRDs. So far, I know there's going to be namespaces support. I've already started working on that. Hopefully I'll be able to sort that out soon. RBAC will definitely be needed because, you know, if you're going to embed this in your application, you want to have some type of security model, and it seems decent to be able to leverage RBAC where possible. Config maps, possibly secrets, and then something to support the defaulting validation and conversion webhooks, because ideally, you know, be able to leverage the tooling. You know, something will have to be figured out there, how to work around the services to, you know, support only externally hosted things. But, you know, that's probably going to be the biggest challenge around making this project viable. And, you know, kind of the keystone is going to be, you know, can we be able to run a non-deploy, you know, the non-deployment related components of a kind of non-trivial CRD based project. And I just kind of picked Cert Manager out of the hat for that. And if it's possible to run Cert Manager with the deployment based components, the webhooks, outside of, you know, this API server, are the components actually functional? I feel like that's a good kind of test. And the last bit, you know, part of the reason why I started looking into this was the whole idea of, can we use this for bootstrapping things? So similar to kind of like the standalone use case, when you do the initial startup, everything is self-contained. Any clients for your application are talking directly to your service. But then, you know, once you've bootstrapped a Kubernetes cluster, you know, the idea is this should be able to reach out to that Kubernetes cluster. It should be able to sync kind of the resources that it knows about, and do that at an API server level, rather than, you know, trying to do etcd synchronization, because then you have to worry about, you know, is the storage version between, you know, this embedded API server and the Kubernetes cluster that's running the same, you know, try to throw all of that out. Just API server based sync of the actual resources that this service knows about, and avoid any of the other various Kubernetes types that the actual Kubernetes cluster may know about. And then once things are synchronized, you know, it doesn't make a lot of sense to have the client need to know that there's two different endpoints to talk to. You know, oh, for bootstrapping purposes, I need to talk directly to the service, but then if Kubernetes is available, should I talk to Kubernetes? You know, trying to put that logic into the client seems a little crazy. So I have the idea that we should be able to continue to proxy requests through to the Kubernetes cluster when it's available. So the Kubernetes cluster itself is kind of the record of origin, and the client is still talking to our service, but instead of communicating directly with the embedded API server, that's, you know, just through the process, you know, worrying about the process of syncing, we proxy those requests through to the actual Kubernetes cluster. And then in the event of, an outage, we should have the ability to rebootstrap the infrastructure and the cluster and continue on. So with that, I'll stop sharing so I can actually see the chat.
This is pretty cool. I think you actually accidentally, or maybe on purpose, covered all the most of the stuff in the chat already. I think one thing you didn't mention was mutating and validating webhooks. What do you think about those?
Yeah, I think that gets into some of the same challenges around the deployment components. I think, I haven't really dove too deep into that because, I was trying to prove out just the initial components to start with, and the namespaces have kind of been kicking my butt a little bit because some of that code needs to be replicated. There are additional controllers involved that I need to bring in there, and it highlighted some ways that I was bootstrapping the delegation services wrong, and I'm trying to have to fix that so that I have informers available so that when admission comes up and the namespace admission controller, all of that stuff is working properly. It's taking a little bit because it's almost like having to figure stuff out on the fly a little bit.
Yeah, I have a bunch of thoughts. My first one is actually, I think you've got two ideas here. The second one is you're actually talking about a write-through cache, almost, right? It's like people have asked us to do that for kubelet, right? Like make it functional even when the control plane is not there, yeah, it hasn't worked so far, right? People want this, but it's really hard actually. Like solving the syncing up cases is hard.
Can I get a
yeah
about like just want to make sure I understand the idea here. When you're talking about adding namespace support, do you see the namespaces present in the little CRD server that you made as consistent with the namespaces in the Kubernetes cluster that you're attaching it to? Or do you see them as distinct, just so that I make sure we're talking about the same thing?
I haven't gotten that far down the rabbit hole yet. And there's going to be, some level of complexity here in that, I feel like anything that, we're worrying about on the scale of synchronizing with the external cluster is going to be a subset of what exists on the cluster. So I would likely say that we would only care about, the namespaces in as much that there may be resources in the namespace that are shared between the two clusters, and that's the extent of it.
Are you open to an idea of having distinct sets? Because this has come up before, and Daniel might remember as well. I think it was a Googler last time, actually.
Yeah, I think distinct sets for this use case are likely fine. Okay. Like I said, like the idea here, like there's really two use cases in mind, because we are taught, like this came about because I don't know if I mentioned the project, the Tinkerbell project, trying to do infrastructure management and be able to handle like the disaster recovery scenarios, and having a hard dependency on Kubernetes there doesn't necessarily make sense, but there's going to be a lot of people who will also be using Kubernetes. So if Kubernetes is there, it would be great to leverage Kubernetes where possible, but we're going to have some folks that don't ever want to use Kubernetes. So that standalone use case is kind of important for us too.
All right. So with Daniel, so I know we're talking about, I'll hand it back to you. So thanks.
I was just going to ask one more thing. This is getting back to, this is close to what David was asking about. When you're talking about adding namespaces and some of the other things you mentioned, so we kind of have a problem in that, like, all of that code is kind of mashed into a package that is also got a lot of things you don't want. I wonder if you'd like if that code were easy to consume piecemeal, would you just do that? Or I wonder, maybe this is a question to everybody, like how willing would we be to refactor this to make it consumable more piecemeal?
So from my perspective, you know, one of the things I mentioned there is I really don't want to have to reinvent too many wheels, and I don't want to have to manage too much stuff. So I would be more than happy to work with y'all to try to refactor some of this stuff out to a more consumable state, if the group is open to it, for sure.
Yeah, because the aggregator and the extensions API server are fairly reasonable to consume, like as they are. It's actually the built-ins one that is not reasonable at all to consume because it's all like mashed together. So this is kind of a question to David. Like
yeah.
What do you think about this?
So I like the idea of this project. I like the idea of building up to it and not building down from it, right? So I'm supportive of the idea of trying to build a server up to provide the functionality that you want. I don't want to try to take a Kube API server and turn things off. That would make me pretty unhappy, because I think risk-wise we would have access. I would like to, before fully endorsing it, I'd like to be able to pin down things about namespace scoping, right? I see a lot of value for this as a server you could install inside a namespace in Kube to provide CRDs in support of something else that you build on top. And that means that things like in-cluster authentication and authorization, I'm not sure that universally makes sense there, right? Namespaces could mean something different inside of this server that you applied. But the idea of refactoring to make it easier, there's been, some of this depends on how tightly we feel like we have to guard the internal types, right? And because what happens is, as you noted, you're pulling in a lot of weird storage stuff, and namespaces are weird. They're so old, they behave weird. When you go in and try to delete them and finalize them, you have a lot of logic around how they work. It's all built around these internal types that provide validation for the types that you're going to be using. And I guess I'm probably of the opinion that at this point, people are used to external types enough. There's a suite of, this is how you use external types. And there aren't even clients available for internal types anymore. That I think the risk of creating somewhere where you can depend on it in some sort of sane dependency chain to be able to build out the pieces you want may be practical.
I think it would be interesting for all the, like, if you're running like David suggested as like just inside a namespace in an enclosing cluster, it might be useful to hook up all of the like RBAC and cert stuff to the enclosing cluster, so that you just get all of that stuff for free. That doesn't get the other, that doesn't get the, like if you want to operate in an isolated situation, like if the enclosing cluster is down, it doesn't help you there. But if you want to like give people an isolated view of their chunk of the cluster, it helps with that.
So imagine a use case though, Daniel, of one that I may or may not have heard of from somewhere, but an idea where you want to have CRDs because they give you good capabilities and good libraries for writing controllers. Like, you don't actually care about the server aspect at all, but you want something solid to write controllers on. And you want your namespaces to represent something different. You don't want to represent the idea of a Kubernetes namespace, but you want to represent, I don't know, maybe machines. Imagine you're running some service that provides physical machines. And you want namespaces for groups of those physical machines. You don't want to wire your access control to namespaces in the hosting cluster, right? You want to have a different concept of authentication and authorization. That's the use
Yeah,
case.
sure. I could see people wanting it either way. Yeah. David and I did a lot of talking. Does anybody else want to add something? We've got another few minutes on this topic.
I could add what we were just talking about. Hi, my name's Michael Cugino. I work for Red Hat. I work for Lifecycle sometimes. And anyway, yeah, what David Age was just saying about, I just want a place to build a controller that's not really connected to Kubernetes, because that pattern lends itself to so many useful abstractions where I have like listeners and informers, and it's just basically the reconcile pattern where I want a declarative state that other actors can communicate and save that state, and you can build a lot of cool things that way. I think as far as namespaces go, in my mind, I'm kind of looking at it as like a separate database SQL server where it's just strictly for partitioning in RBAC. So I might have one group of applications that's talking to this namespace and another to this namespace. But yeah, I wouldn't expect it to be tied to any underlying Kubernetes namespace or server.
All right, thanks. Yeah, that was a little choppy, but I think I got the point. I was generally in favor of separate concepts of namespace from any enclosing cluster. If anyone else want to add a thought?
I think there were two questions in the chat, one about server-side applied and another one about leases. I don't know if we touched base on that one or we want or not.
Yeah, I think leases are in the same boat as namespaces and the other resources. Sorry, Jason, go ahead.
Yeah, I was going to say the same thing. I'm pretty sure leases would fall under that same thing. You know, looking at the controllers that I've been dealing with, they've used config map for like the leader election locking, but leases I think definitely would fall in scope. As far as server-side apply, I'm kind of either way on that one. You know, if we get it for free out of the API machinery stuff, great. If not, then it's not really a huge loss for the use cases that I have in mind.
Yeah, I think you will get it for free. So
I will also come down on the, if this is going to be used by controllers and if controllers are going to use server-side apply, and that is one of the GA requirements you talked about, is getting at least one controller to use server-side apply to prove that it works well. I think that you're going to need server-side apply to be able to participate in that area.
I think we have some internal packages that we would have to get out there, but in general, everything should be easy to use in a custom server handler.
All right, thanks, Jason. How do people want to keep up with this? On the mailing list, Slack channel, something like that? I think it's of general interest, so please keep us posted and or whatever we can help with.
Yeah, definitely. You know, as soon as I get a little bit further in the implementation and get a better feel for what the API is looking like, then at that point I'll be ready to open up more discussions about potentially some proposals of, you know, how we could potentially make some of this more easily consumable instead of having to duplicate it. But
yeah,
thank you for entertaining my apparently not so bad ideas.
Yeah, yeah, I think the presentation quality is making up for the name here. Yeah, so that was pretty cool. Okay, thanks. Next up. Yeah, I'm back to presenting the agenda. Hopefully everybody can see it. So second is a follow-up on a previous discussion that we have. So let's jump into that one. Michael.
Yeah, this is Michael. Thanks for taking my question. So I want to follow up on the interesting discussion the community had back in July. That was about a issue where Kube controller manager might stop working due to like timing out or failures to certain webhooks, for example, OPA or gatekeeper. So I believe the conclusion from that discussion was adding a exclusion-based list to webhook configuration was not the direction the community wants to move forward. But the problem still exists. So I just want quick follow-up on the long-term recommendations the community have. Would that be each webhook user, author, set a reasonable configuration policy, or we're considering like adding, like as Daniel mentioned in the GitHub issue, a kind of a list of critical objects that the cluster operator can optionally enable, saying we're not will bypass certain webhook or like ignore certain webhook policies if the failures or timing out happens.
David, do you remember what our outcome was of that conversation? I recall having the conversation, and I thought we agreed that it was probably a good idea to add the exclusion, but nobody volunteered to do it.
There was a discussion about which actors would be the best to know what was critical in their environment, because it's not always obvious, right? You think about there are different deployment models where you might be hosting something on the cluster, and depending on which vendor you're using, you get different namespaces that are super important, or different mode of something running where it's like a trip dependency, right? Where maybe you're hosting an authorization webhook or some authentication resource or something like that. Yeah, no one actually went off and did it. I think we were okay with the idea of trying to have a way to enumerate it and then have a way to indicate, yes, I want to skip. I don't think we got to the point of agreeing on an automatic way to force that fallback, though.
Yeah, I think it's kind of a hard thing, and we needed somebody we need a champion to like actually drive this.
Why?
And I'm probably not going to look at trying to drive that myself. If as someone's wondering, I don't know about you, Daniel.
Yeah, I can maybe look at designs or caps or something, but I don't have time to actually drive this.
Okay, would that be safe to say the long-term recommendation from the community was we kind of expose a optional list of critical objects to cluster operator so that they can choose to bypass certain webhook policy? That's the long-term direction that we are considering.
I think that's what we're talking about. I don't know that either myself or Daniel is ready to say, yes, that's definitely going to work well. I think part of the request is someone, if they're motivated to look into this, trying to build out what that would look like and see, in a prototype, does it actually work well?
Yeah, I think we shouldn't conflate us collectively making up our minds with actual recommendation. Right, like we haven't made up our minds yet, so it's not really a recommendation.
Yeah, it's like if I were trying to debug this problem or come up with a solution, I would suggest trying to tackle it like this. I think the idea potentially has legs, but I would want to see what actually happens when you try to do that.
So Michael, in summary, what I am hearing from Daniel and David is that they are open to look at a KEP or a design doc trying to propose a solution, but they don't have the bandwidth right now to take that and do it themselves.
Yeah, that makes sense. Thanks.
Okay, let us know if you want to take a shot to that. Okay, and we can go to the last topic of today. Let me open it here.
So basically the question is, people approach me on Twitter, and that was directed at SIG CLI to start with, that they would like to have some kind of a new subgroup for accessing all of the webhooks via kubectl. Obviously, we have the mechanism for using categories, which currently, except for the all, we are not using that much. So I figured out that we could probably reuse that kind of category and expose to people all the different configuration options that we have. David and Stefan proposed that we could probably somehow group these, because maybe webhooks by itself is not necessarily sufficient. Maybe we could have some logical categories that will be grouping resources of similar functionality or related functionality in some logical groups that will help find those information. Because obviously, knowing that it is called mutating admission webhooks or validating admission webhooks is very long, although we have the kubectl API resources, which will give you the list of all the possible resources that any server you're talking with has. But grepping through that, it is cumbersome for sure. So, and to answer Daniel's question, no, there are no short names for mutating admission webhooks, nor for
and I realize as I'm looking at this that I actually can't remember the exact name of the resources that we came up with. So
I
that
cheated
kind of
because
proves the
I
point.
looked them earlier.
Yeah, so I did look at this, and I thought about the request for a category just for webhooks. That doesn't seem very efficient to me, but trying to figure out what I look at them for. I look at them normally to see if the combination of webhooks and CRDs and API services that I have, all the API extension pieces, are present. I think what's noteworthy here, and probably why it came to API Machinery instead of just going against, and the actual API owners, we've never had a second category. I mean, we created it so that CRDs could add their own, but we've never added another one to the core resources because it's kind of an opinionated thing. Oh, I guess we do own these APIs in particular. Hadn't thought about that. I like
the short name is part of the API definition, right? So we wanted to add a short name. I guess that would be us and not SIG CLI.
Yeah. I like the idea of a category for collecting all these things, because I often want to look at, like, what's the status of all these things. It's basically my API extensions, the new APIs I added, the things to validate those APIs. Are they all here?
Yeah, it does sound pretty useful. CRDs can be kind of big. When you list an entire category, does it just show you names, or does it show you the details too? It's been a while since I've used that feature.
It shows you the table view. So every gets one line. It doesn't show you the big detailed view to get explained. So even if you have 50 of them, it shows up on 50 lines, not 500.
Yeah, that sounds pretty good. Of the things you listed there, I think API services are going to have a lot of noise just because there's a lot of them for the built-in ones. Is that true?
Oh,
I guess it's just one per group. I guess that's not too bad.
Yeah, one per version.
Yeah.
Yeah, there's kind of a lot.
Well, with multiple CRDs, API services is smaller than the size of the CRDs.
That's true.
Yeah. I think, yeah, I think it's a good list, and I agree that I often want to see all those things together. I do feel like API services has a lot of default types, which are kind of noise if you're trying to figure out what's different about this particular cluster. But I don't really think that we could hide that in any useful way. So I'm not sure how to improve on that list.
All right. Do we like the name API extensions for the group, or the category rather?
Are there other kinds of extensions? Could we just go with extensions? I guess that collides with our prior group.
Collides with
our
the prior
old group name.
There may be other kinds of extensions.
Yeah, extensions
drivers
pretty generic.
So we could call it cluster extensions.
Sure. Cluster extensions works for me.
Yeah. Anybody have other thoughts or disagree? Anybody in the audience? Walter has a hand.
Yeah, I love the idea, but I question whether this needs to happen in the API server. This seems like it could just be an extension to the kubectl tool itself. But I mean, the APIs to get this information exist, right? So it just seems like we could create a new top level command, which is, you know, I think in my head, like drive.
So Walter, let me say how I think it works, and people can correct me. But I think the way it works is we tag our APIs in the discovery information with what group they're, or what's I don't know what the word for this is, what thingy they're a member of, and then the kube control already has a command which will list all resources of some particular category. Yeah, category, thanks, that's the word. So there's actually no, like the CLI work is already done. The thing that we're talking about is whether to add a category and what to add it as, right? Like we wouldn't be adding additional, there's no additional API calls added here or anything. It's not machinery, it's just metadata that we'd be changing.
Yeah, that's how it works.
Okay.
Yeah, and to add a little bit of color, adding extra aliases per each category that we want to have within CLI seems a little bit overkill as well, given that we have categories built in.
All right, Mache.
Okay, well, it sounds like we're in favor of adding a category that's like API extensions or cluster extensions, something like that.
Okay, I'll open a PR and I'll tag you, including adding the short names for the longer names that we have.
Sounds good. Okay. Thanks. Fede, back to you.
Yeah, I think that is the last big topic that we have for today. If you came yesterday to the back triage, or you're going to come in the future, you will see that now we are starting to use aliases, the labels, sorry, not aliases, the labels for the triage, which is great. I will add a note here. And that's all for today. I will upload this recording later in the afternoon. Will be available for everybody. Anybody else has anything to add? Okay, sounds good. Well, thank you everybody for joining. Thank you, Jason, again for coming and presenting, and everybody for participation. I hope you are safe, stay safe in these crazy times, and we'll see you next time.
Bye.